The Physics of Golf by Ben, Caleb, and Brett. How do golf balls work and how do different impacts affect their ball flights was our research question. We chose this because we're all interested in golf and so much goes into a golf swing that needs to be researched. What we learned in class was projectile motion. We learned vertical motion and free fall. So when a golf ball is struck, it enters free fall, ascending and descending as it travels through the air. Gravity pulls the ball downward, governing its vertical position. The equation for this, which we're trying to find delta x here, which is the change of position, you have the initial velocity, the time, the acceleration, and so looking at both of these, or looking at these terms in golf, the initial velocity of the ball is determined primarily to the club head speed of the impact, where the time interval it refers to the duration of the ball's flight. The acceleration is which we use 9.8 meters squared, which downward, which we learned in class. It's the acceleration of the golf ball during flight. And then the change of position, which we're trying to find, which is the delta x, and it's the distance the ball travels. Also, these two pictures show just projectile motion relating to golf.
The second thing I'll be talking about today is the dimple pattern of a golf ball. It allows the airflow to stay closer to the ball, ultimately allowing the ball to go further. It also reduces the drag of the golf shot and creates backspin.
The first thing that we're talking about is angle of attack. So the angle of attack is relative to the horizon. So if this ground is the x-axis, then you want a negative angle of attack. So you want the ball going down and you don't want the angle coming up. So that optimizes the trajectory. So if you're coming up, you're going to thin it. But if you're going down on the ball, which is what you're supposed to do, then
Alright, two-piece construction golf balls are ideal for beginners and high handicap golfers with slower speeds. The larger core maximizes distance while minimizing spin and movement. The thicker core provides extra protection for on-wayward shots. Weather also highly affects how the ball moves because if it's windy day, then the ball's going to move around. If it's wet, it's going to have less wind speed. It's also going to be heavier. But today is a light sunny day, so we're going to have really, really good golf swings today.
Clubs. This one is a 58 degree and this one is a 60. When talking about those are the different launch angles. So relative to the ground, this 60 degree is going to go way higher than this 58 degree. So when you're hitting these two differently, this one is going to start lower launch angle and it's going to go farther because of how low it starts. This one is going to start a lot higher, and when it's on its trajectory, it's going to bounce right down, way higher.
Dude, that was really fucking good.
Next thing I'll be talking to you about today is club head speed. Club head speed is the exact mile per hour time on when the club impacts the golf ball in that specific speed. Today I'm going to be showing you two different types of club speeds. One's a slower and one's a faster. Here's the slower one. And then here's the faster club speed. The next thing I'll be talking to you about today is altitude. The distance where the golf ball ends up going is way different compared to Pebble Beach to, let's say, Keystone Ranch in the mountains. The elevation is way different, and a higher elevation causes the ball to go way further. So when you play at sea level courses, you typically want to club down, and when you go on higher elevation courses, you typically want to club up.
The spin rate of the ball can affect many different factors of how the ball moves. The higher the spin rate, usually the faster the speed of the ball and also the higher the trajectory. It also links into the control of the ball. If you spin to the right, the ball will usually spin right and come back. If it spins to the left, usually spin left and come back.
All right, impact location has a massive difference on the golf ball. So the sweet spot on the club is directly in the middle here. So that's what you're aiming for. But when you hit it off the heel, the spin, because of the grooves on the club, is going to be massively different. So when you hit it off the heel, it's going to take a sharp right curve or a fade. And if you take it off the toe, when the club's closing, it's going to force that ball to the left and start to fade, or start to drop. So this is what it looks like when it goes off the heel. Directly to the right, not optimal. Now, if you want it right in the middle, perfectly pure, dead center. Now, off the toe, this should launch to the left. Or directly thin. What we did not learn in class is trajectory optimization, which is finding out the best possible trajectory to get to a position in the most efficient way possible. There are two equations to trajectory optimization. On the left is horizontal and on the right is vertical. The only difference in these equations really is that the vertical includes gravity. So the cosine and the sine with the launch angle is the most effective. Those change the equations the most. So if there's a different launch angle, there's going to be a vastly different equation. And these two visuals on the bottom right show an example of trajectory optimization where there's going to be a more efficient way to a ball flight, for example.